Hello, my name is Laura Hackle and welcome to today's webinar of Hole and Weld Enhancements. SDS2 2016 features enhancements to holes and welds including counterbore holes, countersink holes, blind holes, a new chamfer edge tool, and more intelligent weld adding. In this webinar, I will cover how to utilize the machine tool operations for holes, how to use the new weld features, and how the Chamfer Edge tool works. The first thing I'm going to start with is our hole enhancements. Here inside of modeling, I have a single hole, which you can now move. If I select that hole and right-click Hole Move, I'll select my reference point, and then maybe I want to move it over a foot. You can only move holes that are on the same material. You cannot move a hole from one material to the other. So here we have my hole moved over. You can also do that for a whole group. So if I select this bottom left hole and right click, there's a whole group move. So I'll select my reference point and maybe I want to go over 3 feet. I'll confirm that move. And now my holes have moved over 3 feet as the whole group. If there are bolts inside these holes currently, they will not move with the hole. There is a PR requesting this though. If I add in a hole, maybe I want to add a short slot. I can add that in there. But now there is also a matchable here. So if I uncheck that and hit OK, and if I have this go through processing, you'll see that it does not match those holes. The next is a through hole. So I'll go ahead and open up. So I'll do hole add, select my material and do a through hole. I'll just change this to a standard round. So these are all going to be my bottom plates, and then I'll put top plates on top of them and then put holes on top of those or in those as if we were going to bolt those plates together. So we have now a tab that's called Machine Tool. Here we have our operation units, imperial or metric. We have hole depth. I can do a through or a blind. The through will go all the way through. The blind will stop at a specific depth. I have head type. Right now we're going to leave it at no head, so it's just going to be a straight hole all the way through. We have threads, which we'll come to later, and notes as well. I'm going to go ahead and add one more in here for my counterbore hole. It's going to go on top, and then this one I'm going to add it in as a blind hole. So my hole depth I'm going to set to blind, and I'm going to put 3/4 inch here because my plate is 1.5 inches long or deep. So I'm going to only go in 3/4 inch into that plate. So if I snap to this and hover over that, you'll see that that hole only goes 3/4 inch into the plate, and these holes go all the way through the plate. Now I'm going to add a plate on top of this. So I'll do member add rectangular plate, go over a foot, put my width at a foot, and I'll put this at 1.5 inches as well for my thickness. Oops. So here we have our plates that can get added for my countersink, counterbore, and another through hole with threads. So the first one I'm going to add is for my machine screw. So I'll do hole add, select it. You'll notice that I don't have to snap to the surface now because there is no longer a maximum distance from the plate you have to be from as long as you are parallel to that material. So I am going to make this a through hole, but I'm going to add this as a countersink. My diameter and then the angle, I'm going to make this be 100. That's going to be your total angle. Otherwise I could drop this down as well and put it at 100 or whatever angle you'd like. I'm going to turn on threads here. So my major diameter, this will be reading from my hole diameter right here. Threads per inch. The form series, we have coarse or fine series. We'll just leave it at the Unified National Coarse. We also have different classes of 1, 2, and 3. 1 being the generous tolerance, 2 being a normal production, which would be the most common, and 3 would be high accuracy. Direction, right-handed or left-handed. The termination, through, or I could stop the threads at a specific depth. And then we have a note, so I'll put a typical for locations. I'm going to copy this because I'm going to go ahead and paste it on my other ones and click OK. And now when I rotate out, you'll see that I now have a countersink hole with threads. Now to add in my counterbore hole. So this would be for a cap screw. I'm going to add in that hole. Check on counterbore, my diameter, and then we have our depth. Maybe I want that to go in 1/4 of an inch now. We have our threads, and then I'm going to paste this for my note. You'll see that it goes 1/4 inch in. So the depth is 1/4 inch, and then it goes all the way through. For the countersink, that is what the profile looks like. And then the last one we have is just another through hole, but this one is going to be with threads. So I'm going to do my head type as none, put in my note, and then you can see the threads there, and then the threads go all the way through. I'm going to go ahead and member isolate to do a couple section views of these plates. Oops. Okay, and then I'll go ahead and detail. And here we have our detail. So as you can see, it goes over that, so I can just edit this whole symbol. For my symbol location, You'll see that all of this looks the same as in the model. For my symbol location, I'm going to turn this to right and then move this up. And here we also have our section view. So here we have our first line will be for our hole information. Our second line is for our thread information. The third line is for our countersink or counterbore. This would be our countersink. And then the fourth line is the note. If I don't want that note anymore, I can just edit that and delete it. Now this doesn't delete it out of the model, but it does update it on your drawing. And then I could save it. So I'm going to go ahead and detail two others, 19 and 17. So here for M17 would be for that blind hole. We have the diameter that we had, and then that it went down 3/4 of an inch into the plate. And then for M19, I'm going to edit this again. For my symbol location, I'll turn it to right. We do have bottom and top now. And bring this up. And we have that called out. Now you'll see on the third line, it is for counterbore. Now if I delete these, and maybe I want to add in my own hole combo, so I can do hole combo or hole symbol combo. Select the hole. Select where I want it. And you'll see that it still pulls that information in there. If I don't want my note, I can just delete that. Oops. And I have that information now for my hole. We also will export all of the CNC information for these holes as well. And there are two new options in setup for these holes. The first one will be cloud and note vent drain holes on member details. So let's go ahead and save this and get out of it. I'm going to come over here. So I'm going to go to my options, fabricator options, and in our galvanizing options, there's a checkbox to cloud and note vent drain holes on member details. So if I check that on, and I do have a base plate set up here that has drain holes in it, vent drain holes. And now this does have to be galvanized. Hit OK, and then I'll go ahead and show the detail. And I'll detail this without templates. And now you will see that it does provide a note that says vent drain holes, and it is clouded. You will see that the other holes are clouded as well because they are non-standard. You can also cloud and note SC bolts. So in your options, fabricator options, detailing symbol options, there is a cloud and note holes having slip critical bolts on member details. I'm going to check this on and type in no paint within 3 inches. And then I'll just turn these to a moment connection and drop the loads. And then I'll detail this out. And now we have our note here. No paint within 3 inches. The next part of this that we have is our weld enhancements. We wanted to accomplish 2 major things in 2016 for welds. Number 1 was to make the weld smarter in 3D to get a better 2D detail. And the second is to have the 2D weld add match the 3D weld add. The first thing I'm going to go over is the new Chamfer Edge tool. So I'm just going to do it on this HSS column. If I go Model, Material, Chamfer Edge, select my material, and allow selecting edges, I want to do my outside. Click OK. You will want to select every edge for this. Otherwise, since it's just my outside, I can make a box around it. Right click to locate my edges. So I'll say OK. I'll put this at an 1/8 inch for a root face. And then I have 45 for my chamfer angle. Verify my chamfer. And now you'll see that has a chamfer on there. Now I can do this for pipes, I can do it for wide flanges, I can do it for pretty much any material that has an actual edge on it. Another example I have is if I rotate around to the stiffener on the back and do the same thing, Model, Material, Chamfer Edge, select my material, locate the edge, right click OK. I'll leave that root face at an 1/8 of an inch. Verify, and if I scroll in here, you'll see that I have a chamfer. You can take that off by just double clicking on that material and OK, and it'll ask you to regenerate the material and it'll clear all your user modified material operations. If I say yes, then it's back to how it was originally. Now I want to add a weld onto the stiffener. So if I do Weld Add down at the bottom left, select my material to weld, select material to weld to. The first thing that pops up is called a Weld Add Path options. This qualifies the surfaces to receive the welds. So we have our first one is to create a separate weld for each segment. You can weld all around, the maximum gap, the minimum weld length, weld your inside surfaces, try to generate fillet welds, flare welds, plug welds, V-groove welds, or bevel groove welds. I'm just going to uncheck this one and click OK. Now it says select the welds you do not want. So I want to keep both welds, so I'll just right click OK. And it pops up the Weld Add Screen. You'll see that the layout is quite different than previous versions. We have our general settings, pre-qualified weld settings. We have our 2D symbol now. This will update as you change different fields. And then it states what weld you're in. The weld that you're in will highlight in the model. If I went to the next one, it would highlight over on the other side. So for this one, I'm going to change my size for the arrow side to 1/4 inch. You'll see that it updates in my 2D symbol. That's going to be how it shows in the actual drawing. I'm going to put a stitch weld on this with a length of 2 with a spacing of 3 inches. If I just click OK, you'll see that my weld is now stitched and I have a fillet over on the other side. Maybe I want to combine both of those. I can just edit that weld. Over on the right hand side there is a select in model. If I select that, select the weld to make on the other side, I want to select this one. And now you'll see at the bottom here that it combined those 3/16. Maybe I want to, for the stitch, I want it to offset. Okay. And now you see that it does offset. If you don't want those anymore to be combined, you can just edit and separate. And now you'll see that it is its own weld. You can go ahead and show this detail. You see on the left side, we have that 1/4 inch stitch welding, 2 inches long at 3-inch spacing, and then we just have a 3/16 inch weld over here. Since this is on the far side, they are flipped. I can also add welds. I'm going to delete these. Oops. And I can add in my own by doing the same thing. Now these do have their own default checkboxes applied for the specific material types that are getting selected. So I'm going to select the welds I don't want. You will notice that now it's intelligent. It does not go in the Ks or on the toes. The welds I don't want are going to be on the webs. And it pops this Weld Add Screen up again. You'll see that it says weld 1 of 6. Maybe I want to combine these outside welds. So I'm going to go to weld 4 and hit OK. Or sorry, before I hit OK, I'm going to put a finish symbol of G for grinding. You'll see it updates, and I want to combine it with this one over here. You'll see now that they are both, and I'll just go ahead and put a finish symbol of G for grinding as well. I'm going to show this detail. Now here we have our 3/16. If I drag that down, you'll see that if I drag it to the right or to the left, the weld symbol does flip. And here we have our 3/16 called out as well for those combined. Now if I edit this weld, it does have the exact same Weld Add Screen that's in the model. I could put a finish symbol of G for grinding here as well, and it'll automatically update. It does not update in the model, just on this drawing. Here you'll also see there's a weld call out. If I flip this, if I drag it, you'll see a crank appears. So that's to go onto the other side of the joint that's getting welded. This would also show a on bevel material that has a bevel groove weld as well. And then the last thing would be So I'll do it on this one. In my options, job options, there is weld design criteria. For weld all around on base plate, if I drop this down, there's yes with seal or yes without seal. So if I do with seal, it's going to go inside my case. It's going to be one continuous weld. Without seal, it will not go into my case. So I'm just going to put with seal. Go ahead and mark this for processing. And you see that it goes all the way around. I'll do it without the seal as well. And there's weld all around without the seal. That concludes today's webinar on weld and hole enhancements. I'll now look over your questions and answer them the best I can. If I don't know your answer, I will research it and email you.